Ladies and gents, let's finish up Chapter 9A. So this is Chapter 9A, the supplemental chapter before Chapter 9 in the textbook. Lesson 9B, more on slope is what we're heading into today. But first, let's pause. I'm going to ask you to press pause. Do yourself a little favor. I want you to find the constant rate of change in both the graph and the table. Show your work, label your answer, hit pause, come on back when you're ready. So if you look very carefully, you'll notice a ratio of 6 to 1, 12 to 2, 8 to 3, all divides by the same thing. And in this case, it goes up 6, it goes up 1 for a final answer of 6 meters per second. Here we go up from 9 to 18, it goes up 9, and to the right 1. Now don't count tick marks. Look carefully at the x coordinates. It goes up $9 for one shirt, $9 for one shirt. So finding that slope ends up being $9 per shirt. More on that as we continue. Go ahead and pause. Come on back when you're ready. This is assignment 10. Come on back when you're ready for the back page. All right, ladies and gentlemen, more on slope, how we use slope to describe real-world problems, to solve real-world problems. Maybe I give you a table and you graph it and find the slope or constant rate of change from that. Got a quick PowerPoint presentation, hopefully won't take too long, and then we'll get into the remainder of the lesson. This is not on your notes, ladies and gents. This is not on your notes, but I want to talk about the key concept, please. So slope is the rate of change. It is a constant rate of change. It is a change between 2 points. And we often call slope the rise over the run. We call it rise over run because rise, as in the change in the y value, how much it goes up or down, versus the run, or the horizontal change, the change in the x value. And the example that you see in front of you would be a rise of 2 and a run of 1, or you could just write it as 2. So pause if you'd like to read this on your own, otherwise I'll read it with you. The table below shows the relationship between the number of hours Carlos works and the amount of money that he earns. Graph the data and then find the slope of the line. And of course, maybe the most important part, explain what that slope means. All right, first things first. Graphing has become kind of a strength of ours. We have this comparing the amount earned to the hours. In other words, the dollars depends on the hours. That's how you know the dollars goes on the y-axis. That's how you know the x-axis is the hours. All right, now that we have a graph, can we find the slope of that? And the answer is yes. We're going to look at how the x values change and the y values change. Now, this is just a recommendation, but you could write in the x and y above each ordered pair. Now, some of you have the number sense to say, Mr. Callan, I get this. 45 to 90 goes up 45. 3 to 6 goes up 3. Others of you will want to do the subtraction method to find the change. In this case, 45 to 3 does in fact reduce 15 to 1. And what does it mean? Well, of course, we're talking about dollars compared to hours. So this means that for every hour Carlos works, he earns $15. Yes, you could rewrite that or say that as $15 per hour. All right, tell you what, I'll give you the graph here. Pause, come on back when you're ready to find the slope of the line and explain what it means. Now, in this case, ladies and gents, if I were to just use the first 2 points, although we could use any points, the change from 30 to 15 would be 15. Yes, I like to write the units. The change from 2 to 1, well, that only goes up 1 hour. And so the correct statement is choice C. The slope represents 15 pages read per hour. All right, pause if you want to read it on your own, otherwise I'll read it for you. Nina drains a 20-gallon aquarium at a rate of 0.5 of a gallon per minute. Draw a graph of the water in the aquarium versus the time. Then find the numerical value of the slope and interpret what it means in words. Now, the most interesting part about this, I believe, is the word drains. Notice that as water drains, yes, it is leaving, it is going bye-bye, it is decreasing. And so our line should represent that the amount of water is decreasing as the time passes. Now, notice we also have a starting point, not of 0, but it was 20 gallons at the beginning. And then it drains at a rate of, in this case, it goes down 1/2 gallon every minute, another half gallon a minute, another half gallon a minute, another half gallon a minute, and so on. Now, if you're not comfortable with that, you could say that a half gallon every 1 minute is the same as 1 gallon every 2 minutes. But I'll be honest, we tend to prefer unit rates. It just makes a little more sense to us. Notice, please, that when we're writing a numerical quantity that goes down, you better have numbers, symbols, or words that says that it is decreasing. It's got a negative slope, so it should have a negative rate of change. If you were to write this, I would say, congratulations, you have created a miracle. Your draining pool is increasing its volume. So that is a big difference between a positive slope and a negative slope. Be careful with that. All right, another example. I'll give you the graph. Just skip to the last sentence and find the numerical value of the slope. Interpret what it means in words. Now, folks, we could use any of these points. We could go down $20 and to the right 1 week. We could go down $40 and to the right 2 weeks. Or shucks, we could have done the outer 2 points down $20, $40, $60, $80. And to the right 1, 2, 3, 4 weeks. And look at all those ratios. 20 to 1, 40 to 2, 80 to 4. What do you notice, Mr. Callan? They're all exactly the same, especially if you could see that clearly if you reduced them. So it really should not matter which 2 points you use. If you reduce to a unit rate, you'll find the same amount. In this case, the slope of negative 20 represents that the balance owed decreases $20, or they use the word falls, $20 each week. That's it for that presentation. Now we'll go ahead and we'll get going on your notes. Now this is one of the first pages on your notes. You're not allowed to write on it unless, of course, you make your own copy, which is fine by me. Slope talks about how quickly a line rises or falls. Some people call this the steepness. If you think about ski slopes, you think about how steep you go down. Now, remember, please, that slope is a particular way of describing of a ratio. It's a rise versus a run. And yes, sometimes people would say a rise or fall, depending on if it is going down and to the right. All right, let's go ahead and start off with our notes. Pause if you want, read through it, come on back when you're ready, but I'm ready to go through this with you. So we're talking about recycling here. We're comparing, and I always put in this into my notes. First things first, what depends on what? Well, in this case, the recycled amount of paper depends on how many days pass. It's not like I recycle paper and it makes the days change, it makes the calendar changes. No. But the days changes the recycling amount. Therefore, total pounds will go on the y-axis, and days of the month will go on the x-axis. Now I'm going to go ahead and plot my points as carefully as I can. It's not going to be perfect, but it should do the trick. All right. Now, the best that I can do, I'm going to go ahead and draw a line, or in this case, a ray, through those points. If Mr. Callan could draw straighter points, that would be great. Why is the graph linear? Okay, I know it's not my best points, folks, but just pretend that all the dots go through it. Well, it's linear because it really goes up the same amount every day. So I'll say something to that effect. It goes up and to the right the same amount. In other words, the ratio is going to be the same. But let's find that ratio. Let's find that constant rate of change. So first thing I'm going to do is I'm going to identify which is point 1, which is point 2. The first point appeared to be 3 days, 36 pounds of recycling. Second point, 5 days, 60 pounds. Now, if I'm going to, little disappearing ink here, some of you would want to go ahead and write a subtraction for this. The rest of us, we're going to use our number sense. From 36 up to 60 pounds shows a change of an increase of 24 pounds. And then to find the horizontal change from 3 days to 5 days, you guessed it, that's going to be 2 days. 24 to 2, oh, guess what? A lovely 12 pounds per day. So there is a linear relationship, and in this case, a proportional relationship. It's both. Remember, please, as we go through this, proportions are special examples of linear relationships. All right, let's do this. Actually, this is one of my notes. I don't believe you have this one. So again, we see a graph. And again, we want to find a rise and a run. Now, if you're looking on the graph, you can see a rise and a run. It appears to go up 10 seconds for every 2 miles. Now, what if you can't see that? Because, you know, pictures are great, but sometimes looks can be deceiving. You could always use or identify 2 of your points, and it can be any 2 points. Remember what we just talked about? 3 to 1 is the same as 6 to 2, is the same as 9 to 3. As long as you reduce them carefully, you can use any point. So if I use the difference from 10 seconds to 15, let me use 3:15 instead. The distance from 15 to 25, naturally it goes up 10 seconds. The distance from the length from 2 miles to 3 miles to 5 miles is 2 miles. And of course, 10 to 2 does reduce down to 5. What does it mean? 5 seconds for every 1 mile. I don't know if you guys realize that or not. P.S. Don't forget, if it doesn't have it on the table, write it. If it helps you to write the ratio, you might want to write seconds per mile, and that'll make sure that you put seconds in the numerator, miles down in the denominator. Now back to your notes. Go ahead and graph those points. Come on back when you're ready. And I draw a line, or I should say a ray, through those. Okay, graph done. Find slope. Let's do it. Now, some of you can tell by looking at the graph. The rest of us are going to choose any 2 point. I'll just choose the first 2 for simplicity's sake. Remembering that we are comparing centimeters to weeks. The centimeters depends on how many weeks. So I'm going to subtract, you know what? Let's choose something with them easier numbers. I'm going to choose 2, 3, and 6, 4. So the difference from 6 to 3 is an increase of 3 centimeters. The duration or change from 4 to 2, the horizontal change, would be over the course of 2 weeks. Now you can write it like that, you can write it like this. I would prefer to write 1.5 centimeters per week. And if I wanted to, I would quickly turn that into a sentence and say what it means. So the plant height is increasing 1.5 centimeters every week. Another example right here, comparing dollars to weeks. Pause if you want to read your way through this, but the slope of it, $300 every week, $300 every week, $300 every week, $300 every week. It is a constant change, of course. Now let's go ahead and do Jessica. Balance of $35 already on her account. She adds $10 each week for the next 4 weeks. Part 1, graph. Part 2, find the number value of the slope. Part 3, interpret in words. So first things first, please note we're not starting at 0. All right, you guys already know it's not proportional. But even though it's not a special proportional relationship, is it still linear? Let's find out. Some of us might prefer to go ahead and set up a table. At the beginning point, at 0, she's got $35 already in the account. If she adds $10 in the first week, if she adds another $10 and another 10 and another 10, we can now plot those points. We can draw a line through those points, or a ray. Let's find the numeric value of the slope, numerical value of the slope. So I'm going to use, let me just use the first two, huh? Why not? The change from 35 to 45, it's an increase of 10. The change from 0 to 1 is an increase of 1. Okay, got the numeric value, but what does it mean? It means her account balance is increasing. I'm going to let you guys write that sentence. It is increasing $10 per week. So we're graphing out a relationship, using that relationship to find a numeric value for the slope, and then describing what it means. Now, something in real big letters, bold letters on your notes page, the constant rate of change, which can be reduced to a unit rate, it's the same as slope, guys. It's just a different vocabulary, different use of the words. We are constantly looking, is there a same relationship of the rise versus the run? All right, let's do it again. We're comparing small packs of fruit snacks, that's the Y value, per box, that's the X value. Step 1, graph. Step 2, find the slope. Step 3, explain. I'm going to invite you to pause the video, go ahead and graph this, see if you can find it. Come on back when you're ready to check the answer. Picking any 2 points, but notice rise versus run is actually packs of fruit snacks per box. So make sure you don't mess that up. Now from 12 over to 20, some of you don't even need to write this fraction. You see the 8. From 3 to 5, some of you don't even need to write that, 2. Naturally, 8 to 2 reduces, 4 to 1, or 4. So the slope is 4 to 1, or you can write 4. What does it mean? Maybe I should write blank. So again, what are we comparing? That's when we come back and we say, look, it's packs per box. And it is increasing. It is not decreasing. In this case, it goes up 4 packs. Here, let me go with some disappearing ink here. 4 packs for one more box, another box, 4 packs, 4 packs for another box, 4 packs for another box. You get the idea. So how is slope related to rate of change? How is rate of change related to slope? It's the same stinking thing. Rate of change, a unit rate, is the same as slope. Different vocabulary, and I will try to use those vocabulary words interchangeably. You'll often hear me say slope when we're looking at graph, and rate of change when looking at a table, but you should be able to find a slope from a table if you simply envision it, visualize it in your head. So onward we go, assignment number 11. When you're ready, you may begin, and let me know if you have any questions, folks.